In this video, we will go over backpropagation for a feed-forward neural network. Say we are given the following neural network. Notice that this time we are doing binary classification, hence we have a singular neuron for our output layer. Additionally, since we are doing binary classification, our output layer's activation function will be sigmoid. Additionally, let's say that our hidden layer also uses all sigmoid functions. Let's set the stage for training. We need the derivatives of each activation function we use. The derivative of sigmoid is sigmoid times 1 minus sigmoid. We also need a loss function. We will use cross-entropy loss. Cross-entropy loss is the negative of the true label times the log of the predicted label plus 1 minus the true label times the log of 1 minus the predicted label. To adjust the weights, we move their values opposite from the direction of the gradient. The new weights will be the original weights minus the learning rate times the derivative of the loss function with respect to w. But how do we find the derivative of the loss with respect to w in a feed-forward neural network? We use the chain rule. The chain rule is structured as follows. Our function, f of x, is a composite function, u of v of w of x. We can use the chain rule to find out what the derivative of f will be. Then our derivative of f with respect to x will be the derivative of u with respect to v times the derivative of v with respect to w times the derivative of w with respect to x. Let's come back to our neural network now and work through an example of backward propagation using the chain rule. First, we'll go through the neural network for a forward pass to calculate all of the values for each node. Then we'll do the backward pass. When doing backward pass, we will start with the final layer. We know that to calculate the output of the final layer, we use the following equations. Z is the weight matrix for this layer times the output of the previous layer plus the bias for this layer. A, the output of this layer, is the sigmoid of Z that we calculated for this layer. Y hat, the output of the neural network, is A, which we calculated for this layer. We know the equation for cross-entropy loss. And because y hat is equal to A from this layer, we can substitute y hat for A. We want to calculate the partial derivative of loss with respect to Z, so we use the chain rule. Calculating the partial derivative of the loss with respect to A gives us the negative of y over A plus y minus 1 over 1 minus A. And the partial derivative of A with respect to Z comes out to be A times 1 minus A. So the partial derivative of loss with respect to Z is negative y over A plus y minus 1 over 1 minus A, multiplied by A times 1 minus A, which comes out to A minus y. The process of backward propagation would be completed for all layers of the neural network. These videos were inspired by Josh Starmer at StatQuest. Be sure to check them out.